Okay, so now that you've set up an address, you're ready to receive some funds, some money now. To do this on the testnet, we need to head over to what's called a testnet faucet. And since the money is all pretend, you just go to the faucet and request some money, and it should just be sent over to you. Unfortunately, this isn't the way it works in the real world, and on the mainnet, you'll have to find a way to get funds in a different way, whether it be through an exchange, an ATM, or something like local bitcoins, where you meet up with a person in physically and exchange currency for Bitcoin in that way. So I've had a little play around with some testnet faucets prior to this video, because quite a few of them don't work. But if we head over to bitcoinfaucet.uo1.net /send.php, we should be able to get some funds sent to the address we created in an earlier video. So this tells us like the current balance of the faucet and how much we're entitled to get. So when I was testing this website just to make sure I received funds, I've already got some funds in my wallet already. So just to emphasize the need for single use addresses, I will create another address and have the Bitcoin sent to that one instead. So if I head back to the terminal, you can do this as well if you'd like, or you can just use the address that you created in an earlier video. But if I type Bitcoin CLI and get new address and copy this over, copy this into here, and so it says I can get up to 0.0022 BTC. We'll discuss in a little bit why Bitcoin is divisible by so many digits later on in this video, but I'm going to get this amount of Bitcoins sent. So if I click send testnet Bitcoins, it's asking me to just fill in the captcha here. So bicycles there and there, I think, verify, and cool. So it says this number of Bitcoins has been sent to that address. So I'm just going to save this address in my notepad, because when we look at the transactions, I want to be able to reference it quickly. So I'll just save that over in my notepad on the other screen. Cool. So just as a small reminder as well, so when you've finished testing and playing around, you should always try and send the coins back to the faucet for other people to use as well. This one seems to have quite a lot, but it's just, I guess it's just good practice. So we haven't really talked much about transactions, but what transactions are essentially is it's a Bitcoin exchange essentially, and so like the owner of a Bitcoin would use their private key to access the coins, and then they would lock the transaction when they send it using their public key. So again, coins are not held in the wallet themselves, but it's the public and private key that gives you access to those funds to spend. So we can now try and have a look at if we actually received the funds. So there are a few commands you can do. In the latest version of Bitcoin, we have the get balances command. So Bitcoin CLI get balances. And get balances shows us the amount of Bitcoin in our wallet. So like I said, I had already received some Bitcoin when I was testing out the faucet to see if it works. So what you get back is an object with a mine key and a trusted key. The trusted key basically tells you that you've had at least one confirmation and the transaction is included in at least one block. If we had if that wasn't the case, the untrusted key would show us that number of bitcoins, and that would mean that we don't have any confirmations yet. So what do we mean when we say a transaction is included in a block? So transactions are transmitted across the network and gathered into block by miners. So like miners are active members of the network, and these blocks are secured by a mathematical puzzle or a proof of work. And that mathematical puzzle basically proves that there was a level of computing power or energy expanded to create that block. And each block, every time a block is created, they're basically created on top of each other. So it becomes increasingly more difficult to create those blocks because of the amount of energy required to create them, essentially. So I think a visualization might make a little bit more sense here. So if we head over to, where is my visualization? So it's down here. So Block Geeks have got a nice little infographic about this, so we can quickly go through this. So like we just done, someone requests a transaction. The requested transaction is broadcast to a peer-to-peer network consisting of computers known as nodes. The peer-to-peer network of nodes validates the transaction and the user's status using known algorithms, and this is where the miners come into play. And then once verified, the transaction is combined with other transactions to create a block of data for the ledger. So this is the public immutable ledger, also known as the blockchain. So then the new block is then added to the existing blockchain in a way that is permanent and unalterable. And then the transaction is complete. So a little bit more about this sort of area here. This is where the miners come into play, and like I mentioned earlier, they're an active participant in the network, and it's a paying job essentially. So when a miner successfully creates a block, they receive a one-time reward plus any transaction fees that were part of the transactions in that block. Currently, the one-time reward is 12.5 bitcoins. And that is halved every 4 years. So in 4 years' time, it will be 6.25 Bitcoin. And mining in and of itself is quite a big business. It's like special hardware is required for ASICs. Special hardware is required called ASICs that accelerates the ability for miners to solve the proof of work. And sometimes we have what's called like mining pools, where miners will, aggregate their hardware together and split the rewards accordingly. And we can also get similar information using other commands in the terminal. So this is like the latest where you can find out the balance of your wallet, but there is also the get balance command, which will just give you the balance of all transactions that have been confirmed, and then anything that's unconfirmed, we also have the get unconfirmed balance. Unconfirmed balance. If I spell it right, unconfirmed. Okay, and that returns any transactions that are still in the mempool or haven't been included in a block just yet. Cool. So now we have the money has come into our wallet via a transaction. You can discover that transaction by using the list transaction command. So if we get back to our terminal and type Bitcoin CLI list transactions, This shows us all the list of confirmed transactions we have. It's an array of objects essentially. So we've got 2 transactions. So this is the transaction that I was talking about earlier, where I was testing the faucet to make sure it worked. And it was sent to this address, and this amount was received. And it has 602 confirmations. And then the second transaction that was done in this video was sent to this address, which I created at the start of the video. And again, the same amount of Bitcoin was sent, and it currently has 3 confirmations. We can also, and it also shows the transaction ID is shown in both pieces of transaction data essentially. We can also view these transactions with another command, with the list unspent command. So if I clear my terminal and do list unspent, it pretty much just shows me the same thing. We have this transaction ID, the address that the transaction was sent to, and the amount and the number of confirmations, whether it's spendable, and some other metadata as well. And because every transaction you receive is placed on the blockchain, it's public, it's immutable, and it can't be changed in any way, this means like spending isn't always anonymous, because although the addresses are private, transactions can be monitored when they're going in and out of addresses. So this makes privacy not as good as it could be, and it also introduces a level of what's called non-fungibility. So some Bitcoins might be identified as bad because they've been sent to a specific address that has been known to be partaking in criminal or fraudulent activity. So there can be that level of non-fungibility and about some of the Bitcoins as well. And then some of the Bitcoins are, because they're produced relatively slowly, and they get into circulation relatively slowly, the Bitcoins are split into a number of fractions. And so in the real world, 0.022 Bitcoin is worth quite a bit. I'm not sure at the time of writing, at the time of doing this video, sorry. But maybe we can have a quick look just to see what this is actually, how much this is valued in the real world. So if I head over to, let's have a look. So if we do BTC to maybe USD, because that's probably what most people are used to. So let's do a little price check. What I want is, I want to just a conversion tool, don't I? So maybe converter, coin market cap, fine. Okay, and if I enter that amount in the real world, that is worth 1.64 USD. Okay, so not that much. But anyway, so now we can, and so yeah, so the Bitcoins are divisible, and the smallest unit of a Bitcoin is 100 millionth of a Bitcoin. So that's basically to 8 decimal places. Okay, cool. So let's have a little further look at and examine our transaction a little more. So if I do that list unspent as again, so the transaction I received in this video was this one. So if I copy the transaction ID, so I'll just copy that to the clipboard, and if we want to look into that transaction further, I can use the get raw transaction method. So get raw transaction, and then in quotations, I'll pass it a string with the transaction ID. And that doesn't really help us, really, does it? So this is actually a hex encoded transaction. So this has been hashed. So if we want to actually get some data that's useful to us and readable, what we need to do is just pass in another argument, which is going to output the data in verbose mode. So we just need to pass verbose true. And this will give us a list of this will give us some information about this transaction specifically. And in this object, we can see that the inputs for this transaction and the outputs as well. So we can see in the inputs, we have a transaction ID and a script that's used to basically lock this transaction. And in the output, we can see that this value was sent to the address I created earlier here. And we also have another output, which is what's known as a change address. And we'll talk a little bit about the change address in a later video. But yeah, this is essentially like what a Bitcoin transaction is made up of. It's basically inputs and outputs, and those outputs are what we will be able to spend later on. Those outputs are known as UTXOs. So UTXOs, and UTXOs stand for unspent transaction output. So each transaction's input is essentially a UTXO, if that makes sense. Hopefully that's not too confusing. But it might not always make sense to, view your transactions via the command line. Another tool, a popular tool people use to have a look at transactions are what is known as a block explorer. And a block explorer doesn't do very much more than what the command line would do in terms of like displaying your transaction data, but we can have a little look at one now. So if we head over if I copy this transaction ID again, and we head over to blockstream.info. So blockstream.info, I've got a really nice block explorer that we can play around with. So because we're on a test net, we've got this search bar here that allows us to search for block height, hash, transaction, or address. So I'm just going to copy the transaction ID in here and click search. And so this gives me, I guess it's just outputted in a bit of a nicer UI and a nicer format, but this tells me that the status of this transaction has 6 confirmations, which is the standard to be sure that a transaction can't be reversed, essentially, and what block it was a hash of the block it was included in, and the height. So the block height is basically how many blocks deep the transaction was included in, when it was included in a block, and some transaction fees and some more bits and bobs. So as you can see, a lot of this information is similar to what we have in the command line anyway, such as the inputs, which are down here, the outputs that was received to my address, as well as the change address, and the number of confirmations here, and the number of confirmations. So yeah, this is just another tool that you can use to like have a look at transactions and see them in a bit more granular detail. So that's it for this video. So in summary, faucets will give you money on the testnet, and they come in as raw transactions, and then you can examine these transactions using the get raw transaction command, passing in a transaction ID and setting the verbose flag to true. Once you receive a transaction, you can see it in your balance using the get balances command, and you can also use a block explorer such as blockstream.info to find out to see your transaction in a bit of an easier way to digest. So I'll see you. Hope this made sense, and I'll see you in the next one. Peace.